Okay, and we should be live. Let me just check the audio. Is the audio good? Yeah, okay, cool. We Gucci. Right, okay, where were we? So, let me turn that down. So we were on global random numbers. Global random numbers and random headers. We're almost finished with the control flow, and then next we'll be moving on to our error handling. So, what if we only want to use random numbers generator, or remember last episode we spent a lot of time on pseudo random number generators and seeding, and how you need a different seed for your pseudo random number generator, and you can use time or you can use random device. Yeah. So one way to create and seed our pseudo random number generator in our main function. Create static local. Remember using the random. No, was it random? Or was it random was that, but we also had was it was to do chrono. So it was chrono. Chrono was for time and random was for this. Okay, let's continue then. Now that we got that sorted, and we know what we did last time and what we can do this time or now. Okay, here is a simple header-only solution that you can include in any code file to randomize self-seeded MT. So let's create a random header folder, random.h, and then if not defined, as always, random mth. Then if it's not defined, then we will define random mth, and then at the end we will end if, and then we will be including random, and then we'll also be including chrono. Okay, so we're going to be using a namespace for this particular one. For this particular one. Okay, so name space random returns is seeded so create an inline standard MT 19937 function called generate. Then standard random device RD. Then they are creating a seed. So standard seed sequence, and then we're going to convert it with a static cast and convert it to standard seed sequence result type, and then we're going to use we're going to utilize chrono for a steady clock. And then we're going to set it to now, and then we're going to do time since epoch, and then we're going to do count. So it'll look like this on one line. And then we'll do a comma, and then we will do RD, and then we're doing it 1, 2, 3, 7 times. So that's 4, 6, 7, and then it would look like that. And then we'll create and then we will return a standard MT That's fine. No, not there. There. Because we needed that. Okay. And then outside of the inline generate, but still inside the namespace, here's our global MT 19937 object. The inline keywords mean we only have one global instance in the whole program. Inline standard MT, and we're calling generate. And that generates a seed and copies it to our global object. Then what they're doing is generating a random number between, like we did with die 6 in the last example, between 1 and 6. Also handles, and then they're using templates, which I've never done before. So I'm not, it's complicated, but I'm not going to copy it. I'm still going to write it out so I can get used to the syntax, because I've never dealt with a template before. So we do that, and then we create another inline int get, and then we're doing an int min, int max, and we are returning a standard uniform int distribution, and initializing it with min, max, and then mt. So just like we did with die6 in the examples. The following function templates can be used to generate random numbers in other cases. I do know, having looked at the index lessons, that we do eventually do templates. So underneath this, I'll do that. And even though we haven't covered it, we'll still do it. Template, crocodile brackets, type, name, t, then t, and then the get function, t min with parameters of t max. And then we are returning a standard uniform int distribution, calling t, with again initializing min, max, and again calling mt. I'm sure that will make sense eventually to me and to you, hopefully, as we go along. And then that's that. And then generate a random value between min and max. Again, using another template. So it's going to be template type name R, type name S, type name T. And then we're going to do R, get, S, min, T, max. And then we're going to return a get R with it, and then we're going to convert it to a R type. And then we're going to convert min to an R type. And we're going to then convert max to an R type as well. I'm hopeful that I'll eventually understand this. And then we'll do end if. Okay, so that was that. Don't worry if you didn't understand it, because I didn't understand it either. But hopefully in the future, it will be understandable to us both. Okay, so next. So what I just want to do is copy and paste the code into your project, then include random in any CPP file, as you would, and then you call random get max min. Okay, yeah, the challenge. Okay, so by creating a folder, a header file, we've essentially made it sure that we've um, we've created a global random with our namespace, and through the use of inline, we allow it to duplicate into multiple functions, thus allowing to fully seed the standard MT1097 object that we can use in the initializer, a random MT object. Okay, I think I'd have to make a note of that because I don't really understand it. But it's good to have, at least. Okay. Okay, nice. Right. So now, now we'll move on to the quiz, summary and quiz. So, the specific sequence of statements there is called an execution path. Control statements. A conditional statement is if statements allow us for true and if statements for false. If else statements can be used, yes. A null statement is a statement that consists of just a semicolon. Yeah. That's annoying. And use switch statements can provide a clean, fast method. Yeah, so you don't necessarily have to, in C++, include a default statement, but in other languages such as Swift, you do have to, I have found. Yeah. So a break statement can be used to prevent fall through, whereas a return statement ends the function as a whole. Ghost statements. Yeah, ghost statements are avoided because they create spaghetti code because you don't know where things go. While loops, if you did while and then true, that creates an infinite loop. An infinite loop is something that is always true. These loops will continue forever unless another control statement is used to stop them. A loop variable, also a counter, is an iteration. So we have do loops, and for loops. We have break statements, which allow to break out of a switch, while and do while or a for loop, and then continue statements allow us to skip over an iteration but continue with the loop. Then we have halts such as standard exit and standard at exit, which allow us to exit the code. Then we have abnormal termination through the use of standard. I think I'm just not trying to look to remember. You have standard terminate and standard abort, which abort is abnormal and terminate just terminates. Abnormal termination. An algorithm, like we did last time, remember an algorithm you need a seed, and you don't want it to be diametric, deterministic, because that will always produce the same output. And the best algorithm is a stateful algorithm, which retains information across calls. Then you have a pseudo number generator. The size of the seed value can be smaller than the size of the state. This creates a underseed. And a random number distribution converts output from a PNG into some other distribution numbers. A uniform distribution is a random number generator, random distribution that is even, i.e. if you're rolling a dice, 1 through 6 is likely to happen with equal probability. Okay, quiz time. In chapter 4, we wrote a program about a ball falling off a tower. But we didn't have loops yet. The ball could only fall for 5 seconds. Take the program below and modify it so the ball can fall for as many seconds until it reaches the ground. Update the program to use all covered best practices, namespaces, constant expressions. Okay, so we're getting a bit difficult now. Okay, let's just give it a go. Why not? And let's just remind ourselves. I'm going to create it again, just so include input output stream. So actually I'm just going to copy it just to save time. So, okay, so I assume what we want to do is we'll want a constant expression of gravity. So what we could do is we could do namespace constants, and then we'll do a const expression of gravity of double gravity, and we'll do 9.8. So then here we can get rid of this and we can call constants gravity. Are we calling gravity anywhere else? No, we're not calling gravity anywhere else. So we can get rid of that. Um, will we want a will we want to make this a global? So I think we'll want the for loop in here. So for and then initializer int I, and then whilst the wall height is less than or equal to tower height, we will be deducting wall height. Maybe not. The issue is we have a double, so we could convert it. Maybe if we converted it to an integer. Now, what if we initialize I as wall height, and then whilst wall height is less than or equal to tower height, we will be deducting static cast int then we'll be converting that. But it's a constant expression, so it can't be modifiable. So does that mean we need to make it a global expression? If we did namespace globals, and then we did x, what was it? Xturn, double, and then if we do tower height, but we'll need to initialize it. But we can, because it's global, we can do that. And then we could possibly get rid of these. And then we can just call globals tower height. like that, and then globals tower height like that. So we could get rid of that. Then if we did ball height, I think I'm going to get rid of that for now. Get tower height. So that is that. What if we also it's a constant expression. We wouldn't put the for loop in here because that's the get tower height. Because that's the get tower height. Would you put the full distance here? But then you would have to do const double. Extend double fall distance. And then here you could just do this. Would that be right? And then here, no, it must be modifiable. So if you got rid of that, then you do the same again, but for ball height. This doesn't feel right though. Hmm. Um, so I think here would be probably where you would do the for loop. So would we do instead of a for loop or while loop? So while while globals is falling is true, then we will do a standard character output see what happens if we print it. Yeah, so it's pretty much wrong. I'm going to have to look at the answer, I gotta be honest. Okay, so it was that. Okay, so I was right on that, on the constants, double. So I'm going to get rid of all my global constants. And this for loop. So we didn't have to modify. So that was, I'm glad I got that at least. At least that's one thing. And then we literally just do in here. So int seconds. So int seconds. And then we initialize it as 0. And then we did need a while loop. So at least I was somewhat there. Calculate ball height and print. Height. Then we have tower height. And then we have seconds. Whilst it's greater than 0, we will add to seconds. We are getting an error here. Double. Expression must be arithmetic, unscoped, but has type of void. You're right, it does. Const double tower height must be arithmetic. This has a type of void. So we must convert it to a double, and then we will return. We need to return something, don't we? We return ball height. We need to convert this to a double from a void. And return ball height. So then we run the code, enter it in meters, 100. We're still getting at 5 seconds. That's because but is that always the same? So if we did 2, oh, it is, okay. So at 150 meters, there we go, we go past 5 seconds. Okay, so I got that, which is good, and converted that easily. But I needed a while, and I sort of knew I needed a while loop. But I need to create a variable that can be used for the while loop, and we're using tower height there and seconds there, just like in our parameters. Okay, a prime number is a natural number greater than 1 that is evenly divisible, whose remainder is only by oneself. Complete the program by writing isPrime function using a for loop. When successful, the program will print success. Okay, so So here I think we need to utilize the ability to recognize true as being 1 and false being 0. So we're setting it to be, we'll set it to be true for now. Um, and so whilst I is greater than x, because if we make x false, we will do I'm thinking if I write if I no. Oh no, I think I'm going to have to look at the solution, to be honest. Um, okay, so I was sort of on the way there. So, as I said, using 0 to be false and 1 or more to be true. So we didn't need an if statement in the for logic. So if x is less than or equal to 1, then we would return true. No, return false. Oh, because if it's less than 1, yeah, we return false. If x is equal to 2, then we return true. If x modulus 2 is equal to 0, i.e. being false, we would return, i.e. if you divide it by 0, or if you divide something by 2 and the remainder is 0, it means it's not a prime number, so it'd be false. And then for any number 3 or greater, the test odd values. This is why we add 2. Oh, sorry. For any number 3 or greater, test the odd values. This is why we add 2. Between 3 and square root x, we need to see if they are divisible. Since test is greater than 0 and x is greater than 0, so for int test initializes 3, we do test times test, so 3 times 3. And then if 3 times 3 is greater than x, i.e. this number, these numbers, so if 3 times 3 is less than or equal to x, then we will be adding 2, so it'll be 5. And then if x modulus test is equal to if x divided by test has a remainder of 0, then we return false, i.e. the number is not prime. So for int test, and we're initializing it as 3, we will be doing test times test. We will be seeing if test times test is less than or equal to x. And then if that is the case, the iteration will be adding 2 to test. Then if x divided by test has a remainder of 0, that means it is not a prime number. We return false. And then if we didn't find any divisors, we return true. And then we'll put, yeah, this was definitely more difficult. C math. Okay, I'm going to take a break before this high-low game. Alright, so I'll be back in a minute. Okay, and we're back. How are we looking on the volume? Let me just check the stream. Okay, good. We're still good. Yeah. Okay, let me stop that. I don't want any feedback. Okay, let's continue with the high-low game. So hopefully this should be, well, implement a high-low game. First, your program should pick a random number between 1 and 100. So we need an algorithm and we need a seed. The user is given 7 tries to guess a number. So 7. So we need a for loop that that uses guesses so will we need a while loop and a for loop? So what I was thinking was, so we've already so if we did include input output stream, and we also included I'm not sure if this would be correct, but if we did include CMath, no, include random maybe first, and just so it's alphabetical, and then we'll do include chrono or MT 19937, I think it is. So first of all, we'll have a main, we'll put it all in main integer for now. So we'll need a standard character output of that. And then we'll put those in brackets there. So we will do int guesses, and we will initialize int as 0. Int 0, and then we'll do, we will we'll maybe do also int correct, and we'll set that to 0 for now, i.e. false. No, we'll do a boolean, sorry, that should be a boolean. And then we'll want a boolean of play again for playing again. So, we'll do a for loop for now. We might need a while loop. Might need to wrap the for loop inside of a while loop. So for int, and then we'll do tries, and then we'll initialize that as 0 because the first time they guess will be the first iteration will be should it be it'll be try one. The first go will be, we'll do go actually. No, try. And then the first try will be 1. And then when they've made one guess, it'll go into try 2. Yeah. We can't use tries, so we'll do, because try is a keyword. So whilst tries is less than or equal to 7, we will be going through we will be increasing tries. Each loop, we will allow the user to input their guesses, then if guesses if guesses is equal to correct, then no. If tries is less than or equal to 7, then we will do a standard character output of no, hang on a minute. So it says here we want to use this. And as an example, so we want to actually call our random. Random.h. So we'll want a standard character output random dot get, and it'll be 1 to 100. So what happens if we run this, just out of curiosity? I know it's not finished. So it's 63. It is 63. So it's producing the output. So we want a standard character output So we'll move that up there, and then we'll do standard character input, and then allow the user to input guesses. So we'll exit this, clear that. No, we want to store, so int number thinking, so int number, and then it's initialized as that, and then so your int number, maybe that will run a bit better now and allow the user to guess. So then we need a standard character output of, so this will be this standard character input this time of we'll actually do guess because that's probably a better variable name. So I'll run that. What is it? And then we'll do 30. So at least we've got that now. So if guess is equal to num, then we will say standard character output standard character output, and we will do correct. You win. You win. Else standard character, but you win. You win. Else we will want to say and so else standard character output guess number and then tries and then that, and then we will allow the user to enter their guess again. I still feel we need a while loop to make it all true. Okay, then outside our for loop, which is why I feel we need a while loop. So we got these 7 tries correct. I feel we need to loop all this in a while loop. So while maybe if we did bool current game and we set it to false, then if we did this while current game is going on, while current game is going on, and then return 0. Think of a number, tell me what it is. So actually it should be standard character input guess and we remove that. Maybe we just need a for loop and we don't actually need while in the end. So that's working. Tell me what it is, and then we'll have a line break. So guess what? There we go, that's much better. 20, 66, 89, 45, 29, 1, 6, no. So then, so we got that, correct you win. Then outside the for loop, we would do we need one outside of the for loop. Basically, once the for loop is over, if tries, although we can't call tries, so if not correct, we would produce a standard character output of if correct is equal to 0. If correct is equal to 0 and tries is equal to 7, then we will produce a standard character output Actually, I think, what if we did a break here? Standard character, but sorry, you lose. You lose. The correct number was, and then num. And then we will do a full stop and a line break. See if that works. So got rid of break. Okay. So if we do 1, 1, 1, 1, 1, 1, 1, the correct number was 78. And tries is less than or equal to 7. How about that? Sorry, is greater than or equal to 7. And as you can see here, we're getting different numbers each time, so that's good. At least we know that's working. That's thanks to our random header, random number generator, and calling it here. So, we did 56, 98, 44, 71, 39, 26. So it's not allowing us to get to 7. The correct number was 37. So now that should allow us to get to 7 the correct way. What I think I'll do is, no. If guess number, if correct is equal to 0, i.e. correct is false, and tries is less than 7, if correct, I just thought maybe we need a switch statement, is equal to 0, and tries is less than or equal to 7, then we will print standard character output. No, hang on, stop. That's wrong. I just realized what I was going to do was wrong. So if correct is equal to 0, if correct is equal to 0, and correct, and guess, sorry, if correct is equal to 0, and guess is greater than our number, then we will print standard character output. Your guess is too low. If correct is equal to 0, and guess is, sorry, if guess is, no, that's wrong. If guess is greater than number, then that means it must be too high. If guess is less than number, then the standard character output we will print shall be your guess is too low. Quite a lot of if statements put together. So let's have a look, see if that is correct. Okay, so we're getting there eventually. So now we're getting this. So what if we do bool too high and bool too low? So 50 was too high. So 20 is too high. 12 is too low. So 15 is too high. 13 is too low, so it must be 14. Let me just, your guess is too low. So I think what we need first is we need to convert this into an if statement rather than an else statement. And then we need brackets here. So if, no, we don't need, we just need that, don't we? Because then that'll just, that'll be what will loop through each time. So guess 1, let's do 99 again. Your guess is too high. So what we actually want is too high. So then if we want, if we have a line break here and a line break here, a line break here and line break here. So let me just run that again. So 99, your guess is too high. So we're getting there. 99, your guess is too high. 50, your guess is too high. 20, your guess is too low. 40, your guess is too high. 35, your guess is too high. 27, your guess is too low. 32, your guess is too high. So then what we want is if no, because it's not printing, is it? If correct is equal to 0, so if not correct, so we're not getting our sorry you lose anymore. 70. Too low. 74. Ah, you win. So it was 74. So if guess equals number, then we want to actually break here. And we also want to break here. Because look, we've continued there and we get 74 again. Correct, you win. So what we want is if you win, we're getting there, I feel. We're slowly but surely getting there. Correct, you win. And then if you win, we'll do a standard character output of would you like to play again with yes or no. Then we'll allow the user to enter play again, and then first of all, this if statement is getting way too big, so we need brackets, aka more than one line. And then within this if statement, and then within the if statement, if no, stop. What we want then is a char continue if char if char playing in is equal to yes, no, if play again is equal to yes, then we will tries equals 1. Else if play again is equal to n, we return. Let's have a look if this is gonna work. Then we break. Or what if we return 0 for false, because we don't want to play again? So 88, your guess is too low. But it's stopped there and it hasn't continued. Okay, so is that the issue there? No, so the issue here is okay, so it was that break. So it's between 22 and, so let's do 26. Congratulations, you win. What a guess. Congratulations, you win. I want to play again. So tries equals 0, it should be. No, 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 no. What if we do uh, guess equals 1? If play again is equal to no, then we will do break. So let's do 33. Your guess was too high. 22, too low. 30, too high. 27, too high. 24, too low. 25, you win. I don't want to play again. We end the game. Cool. Now we've got everything. Well, it seems like we've got everything, but we have not. We have not. I just want to make sure it's not 25 all the time. No, okay, good. 4. Oh, yes, it's too low. So when we reach 7, uh, so if correct doesn't equal num, no, if correct equals 0, no, let me try this. If tries is greater, no, if tries, the first try, so if guess is equal to 7 and correct is equal to 0, sorry you lose, the number was. Let's see if that works. Okay, so let me just stop the program there. And then I'll just change that to equals. Exactly is equatable to. Is equatable to. Okay. Let me run that again. So guess 1. Your guess was too low. So if guess is and if guess, no, because that's saying if guess is 7. Look, that's wrong, because if we put 7, the correct number was 89. Giving it away, you just do 89. So if tries is equal to 7 and guess does not equal num, sorry you lose, right? If tries is exactly equal to 7, sorry, okay, good. So then now in here we can do standard character output. Would you like to play again? Yes or no? And then we can have, we don't need a line break here because we will be asking the user for play again. And then if play again is equal to yes, we will be doing guess equals 1. If play again is exactly equal to n, and we're using equatable rather than equals because the character is an integral type, because y is actually a number in ASCII. So here we have y and we have 1, 2, 1. So if that, then we break. That is causing an issue because we need that. And the code is getting a bit janky, so I'm going to do that. And actually what I need to do to make it look better is I do that and I do that. I want to do that. I want to do that. Okay, so guess equals 1. If no, then we say 4 with a break. So we'll actually need a body here, a block for our body. And then we'll have a standard character output. Thank you for playing today. So what I actually want then in here perhaps is, you can see here in his example, we have, sorry, where are we? We have, let's play again. So I actually want a standard character output of let's play a game. Tell me what it is with a line break. And I actually want to do that for our other play again. And I've just realized I have a I am doing dry code. So I don't want to I want to emulate dry code. But as you can see here, we're doing the same exact thing. So what I want to do is I will create a void function to print what do I want to print? What is the name and the purpose of this whole function? Print print play again question. And this will return a character of ch. And then we want to create a boolean. So no. If ch is equal to y, then we'll do that. I think what I'm doing is on the right lines. If ch is exactly equal to no, then we will say thank you for playing. So then in here we will call print play again question. Why? No. Play again. Yes. Yeah, play again. So in that case, maybe we should create a maybe a global variable. So in here you do that, and here you do that. Oh no, I'm just playing around, to be honest. And I just want to see if what I'm doing is actually valid. So I'm going to get it wrong. So 1, 1, 1, 1, 1, 1. The correct number was 100. Would you like to play again? Yes, I would. So then we should get this. But then it stops. So I think maybe we need to create a, what if we just did, hypothetically, we did that. That I believe creates a, no, that should be guesses, shouldn't it? Because we're increasing, I pressed yes. If we did that, and we commented out that 100, 100, 100, 100, 100, 100, 100. You lose, it was 28. Would you like to play again? Yes, I would. But it's not allowing us to then. Oh no, that's why, because guess equals 1. So we can then get rid of that, and we can get rid of that. Then if we do that, yes, I would like to play again, but it's not letting us go. That's because it's void. If we did int and we return guess, would that work? Let's have a Pat Butcher. No, still doesn't. What if we press no? Thank you for playing. Okay, for now, I'm just going to get rid of my void function, and I'm going to accept the repeat code for now. I just want to make sure at this point we're still all Gucci. Yes, I would like to play again, but even still, that doesn't. What if we get rid of that, and we get rid of that, and then we guess 1 again. No, it still doesn't. So I swear it was working before. Ah, that's why, because we didn't have standard character input. No, we did. Hmm. Dun, 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 dun. Let's play a game. Is it because we need to run the loop again? So guesses equals 1. Guesses is like that, maybe? No, so tries must be that. Yes, I would like to play again. And then we go to guess 2. So tries equals 1 and guess equals 1 as well. Tries equals 1 and guess equals 1 as well. Perhaps that will no, guess 2. So guess equals 0 to begin with. Guess 2 still. Get rid of tries. 1, 1, 1, 1, 1, 1, 1, 1. Yes. No. What about tries equals 0? Cool. There we go. So it was tries equals 0. So tries equals 0, which means when we loop through again, we get try, we're adding to try. Yes, that makes sense. So one more thing I want to do is if guess is greater than our, if guess is greater than 100, or guess is less than or equal to 0, then we will simply print please pick a number please pick a number between 1 and 100. Now let's see if that actually continues the loop. So 101. No, so that's wrong. So it wouldn't, if guess is, what if we did this and we moved it, because we know code runs in sequential order. If we did that, and then we did -10. And then here, what we want to do then is we want to make we want to set guess equal to guess, i.e. we don't want to increase guess. So 101 guess equals tries, perhaps. No. If guess well, how about we just, if they pick a number between 100, for now, that's just the way it is. So I want to get the number right this time. 45, too high. 30, too high. 20, there you go. Yes, I want to continue. 30, again, too high. 20. See, now we're getting the exact same. 20 again. So that means see here. So does that mean so if you get the number correct, then your tries go to 0, your guesses go to 1. But first of all, what we need to do is we need to number equals random dot get 1 to 100, right? Because if we get it right, we don't want to keep getting it right. Do you know what I mean? So we don't want to continue that. So let me say no. So if no, then we break. If no, then we break. So let's just make sure it doesn't. So 20, too high. 12, too low. 15, too low. 18, too high. 16, too low, so it must be 17. You won, so let me play again. If I enter 17, good. Too low. How about 11? Too low. 9, too low. 4, too low. 3, too low. 2, too low, so it must be 1. Oh, sorry, I thought it said too high. My bad. But at least we know that it's getting a different one. Thank you for playing today. Cool. I think that is the first successful for loop are actually done without any without needing to see the solution. Nice. I'm happy with that. Cool. Let's see what he did. So we got the random H. We didn't actually end up needing to use this, I suppose, because we use it here. We don't actually need this because it is used in random H. Cool. Let's see. Oh, so he did a Boolean. Ah, there we go. That's what I did wrong. So I did it all in there. So he essentially did a better version, basically. I had put it all in main, whereas he had then converted everything to functions. Play high-low. So I just want to aka. So let me just copy and paste that because that's what I did. Then high-low more advanced version with functions. Okay. Okay, I think we'll call it a day here, to be honest. So next lesson, next stream, we're going to be doing introduction to testing your code, i.e. error handling. So left off at lesson 9.1, intro to testing code. Okay. So what did we do today? Day 18 was just quiz. No, day 18 wasn't just quiz. We also did global random numbers via a random header. And then most of the stream was the quiz. Okay. Tutto bene. And the date today is the 18th. The 16th. 2026. Cool. Nice. So, commit. We can close that. We can close our file explorer. Yeah, hopefully you enjoyed that. That was a bit more challenging, a bit slower, but I'm glad, even though I didn't do it like this, the more advanced function version, I'm glad I at least got it like this without having to look at the solutions. Hopefully, if you followed along, you did too, or maybe you split off from me and did the functions yourself. If you did, good job. But yeah, hopefully you're enjoying it as much as I am. Again, if you saw something I did wrong, tell me. But yeah, hope you enjoyed. Please like, subscribe, comment, all that good stuff, and I'll see you later.